Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to design 7-pole lumped element low pass filter at 1 GHz operating frequency using HFSS software. In my previous video, I have already designed 3-pole lumped element low pass filter. So why we can use 7-pole lumped element low pass filter? So compared to 3-pole lumped element low pass filter. So to obtain a sharper rate of cutoff, a higher degree of filter can be designed in the same manner, a similar manner. So similar manner means 3-pole like that, 3-pole lumped element low pass filter. So now here this is the general structure of the 7-pole lumped element low pass filter, and this figure B is the microstrip realization of this 7-pole lumped element low pass filter. So now here the four open circuited stubs. So these are the open circuited stubs. The four open circuited stubs which have the same line width W suffix C, that line width is 5 mm, are used to approximate the shunt capacitors. So now we are the C1, C3, C5, C7 are the shunt capacitors. So that width is line width is WC, which is 5 mm, and three narrow microstrip lines So that narrow microstrip lines are L2, L4 and L6. So three narrow microstrip lines of width W suffix L are for approximation of the series inductor. The low pass filter is designed to have a Chebyshev response with a passband ripple of 0.1 decibel and a cutoff frequency at 1 GHz. The lumped elements. Now the lumped elements are C1, C3, C5, C7, L2, L4, L6 are the lumped elements. That lumped element values in this figure. So these are the lumped element of the figure A. So now here I am going to design 7-pole lumped element low pass filter, microstrip filter design. So using the substrate, I am considering if the substrate is Rogers RT or Durite 6010 and its relative dielectric constant is 10.2 and the thickness is H is equal to 1.27 mm. So now here the 7-pole microstrip 7-pole lumped element low pass filter can be designed into two cases, and the design one I am considering the microstrip line width is 0.1 mm, and second one is design 2, the microstrip line width is 0.2 mm. So in the first design uses the high impedance transmission line having the characteristic impedance of 110 ohms. So 110 ohms using microstrip online calculator using the basic parameters. So now here in this design I am using the operating frequency is 1 GHz and relative dielectric constant epsilon r is 10.2 and thickness of the substrate is 1.27 mm and characteristic impedance of the high transmission line is 110 ohms. So using these parameters, using online microstrip line calculator, calculate the length the width of the line, width of the inductor. So using these parameters, the width of the inductor is W suffix L is 0.1 mm. So that is the design 1. So now here in this video, I am going to design 1. So design 1 means the width of the inductor line is 0.1 mm. In my next video, I am going to design second design. In the second design is the characteristic impedance of the transmission line is 93 ohms. In that 93 ohms using microstrip online calculator using the parameters operating frequency 1 GHz and epsilon r is 10.2 and height of the substrate is 1.27 mm and characteristic impedance of the transmission line is 93 ohms. So using these parameters we can calculate the width of the line is 0.2 mm. In this the second design I will explain. I will design in my next video. So now here I will design 1. Now open HFSS software and this is the general structure of the this is the general structure of the 7-pole lumped element low pass filter. So now here this end is the 50 ohm transmission line and this end is the 50 ohm transmission line. Okay. So the width of the 50 ohm transmission line is 1.1 mm. So I am considering the length of the 50 ohm transmission line is 10 mm. So this is the general layout of the 7-pole lumped element low pass filter microstrip realization. So now here this end and this end is the 50 ohm transmission line. So the length of the 50 ohm transmission line is I am considering 10 mm. 10 plus 10 20 plus. So now here I am using 4 short circuited stubs, 4 open circuited stubs. So this length of the open circuited stub is 5 mm. So now the 4 stubs 5 into 4 20 plus and L2. So 0.1 mm width and length is L1 is 5.86 and L2 and L2 and L6 length both are same. So L2 is 13.32. Sorry, not 5.86. L2 is 13.32 plus and L6 is 13.32 plus and this length is this width and this open circuit stub already used and L4 length is 15.09. So the total length of the microstrip line is 81.73 mm. So now here I am considering the length of the substrate is 81.73 mm and width of the substrate is length of the substrate is 81.73 mm and width of the substrate is 60 mm. So now open HFSS software, select the box, draw the box anywhere in the plane. So give the rename of this box 1 substrate and change the type of the material. So now here I am selecting Rogers RT Durite 6010 and its dielectric constant is 10.2. So now change the dimensions of the substrate. So the length of the substrate is 81.73 mm and width of the substrate is I am considering 60 mm and the position and height of the substrate is 1.27 mm minus 1.27, and x position is half of the exercise value before representing negative sign minus 81.73 by 2, and y position is half of the y size value before representing negative sign minus 60 by 2, and z position is 0 mm. So click OK button, select fit all. So this is the substrate. So below the substrate we can design ground plane. Select the rectangular sheet. So draw the rectangular sheet anywhere in the plane. Give the rename of this rectangular sheet. This is the ground plane. So change the dimensions of the ground plane. The dimensions of the ground plane is same as that of the substrate length and width. And the substrate length is 81.73 mm. Substrate width is 60 mm. And the ground plane length and width is also same, 81.73 mm, and width is 60 mm. Axis is the z axis, and position value and half of the x size value minus 40.865, and y position value is minus 30 mm, and z position, that is below the ground plane, below the substrate. So the z position is minus 1.27 mm. So rotate this structure, and this yellow color is the substrate, and below the substrate is ground plane. This red color is ground plane. So on the top of the substrate we can design microstrip realization of the lumped element low pass filter. So this is the general structure of the 7-pole lumped element low pass filter. Okay, at both the ends of the substrate, first we can design 50 ohm transmission line. So using the basic parameters of this design, the basic parameters are 1.2, height of the substrate is 1.27 mm, and dielectric constant is 10.2, and frequencies, operating frequencies 1 GHz, 50 ohm transmission line. So using these basic things, using microstrip online calculator, calculate the width of the 50 ohm transmission line is 1.1 mm. Select the rectangular sheet. So draw the rectangular sheet anywhere in the plane. So give the rename of this rectangular sheet. This is 50 ohm transmission line. So now change the dimensions of the rectangular 50 ohm transmission line, and axis is the z axis, and the length of the 50 ohm transmission line is, I am considering 10 mm, and the width of the 50 ohm transmission line is 1.1 mm, and position and x position is half of the substrate length, and the substrate length is here 81.73, and half of its value is 40.865 mm, and y position value is half of the y size value. Now the y size is 1.1 before representing negative sign minus 1.1 by 2 comma z position is 0 mm. So click OK button. So this is 50 ohm transmission line. Similarly draw the 50 ohm transmission line other end. Select this 50 ohm transmission line, press Ctrl C, Ctrl V. So copy paste this 50 ohm transmission line. So change the dimensions of the pasted element of the 50 ohm transmission line. So now here minus 40.865, and this is 10 mm. So this is another end of the 50 ohm transmission line. And after that design open circuited stubs, and this one, and this one. So these four are the open circuited stubs. So the length of the open circuited stub. So WC is the 5 mm, and L1 is 5.86. Select the rectangular sheet. So draw the rectangular sheet anywhere in the plane. So give the rename of this rectangular sheet. C2. So this is C2, sorry, C1. Name is C1. So change the dimensions of this open circuited stub, and axis is the Z axis and X size is 5 mm minus 5, and Y size is 5.86 minus 5.86, and position X position is, and this 50 ohm transmission line X position is 40.865 mm, and this length of the 50 ohm transmission line is 10 mm. So the this open circuited stub X position is 40.865 minus length of the 50 ohm transmission line minus 10 mm. So the X position is 30.865, comma Y position, and Y position is half of the 50 ohm transmission line width, so 1.1 by 2, and Z position is 0 mm. So press OK button. So this is open circuited stub, and copy this open circuited stub. Select this open circuited stub. Press Ctrl C, Ctrl V. So give the rename of this pasted element C7. So change the dimensions of this element C7, and X position is, axis is the Z axis and X size is minus 5 mm, and Y size is minus 5.86 mm, and X position. So now here the other end is minus 30 point, X position is now here minus 30.865. So now here the X size is 5 mm minus 5 mm, so plus 5 mm, so which is equal to minus 25.865 mm. So this capacitor C1 X position value is minus 25.865, minus 25.865, and Y position is 1.1 by 2, Z position is 0. Now press the OK button, and this is another end of the open circuited stub. And after the open circuited stub C1, we can design inductive element L2, and this is C1, capacitor C1, and after that we can design inductor element L2. So this inductor element L2, width is 0.1 mm and the length is 13.32 mm. Select the rectangular sheet, draw the rectangular sheet anywhere in the plane. So give the rename of this rectangular sheet. So this is element C3, L2. So not L2. Element L2. So element L2 inductor. So now change the dimensions of the inductor L2. So the inductor L2 axis is the Z axis and X size is 13.32. So minus 13.32 mm and Z portion, the Y size, and the width of that inductor is 0.1 mm, so minus 0.1, and the position. So X position is 25.865 mm, comma Y position is 1.1 by 2, Z position is 0. So now press the OK button. So this is inductor L2 element. And copy this element inductor L2, press select inductor L2, press Ctrl C Ctrl V. So give the rename of the this pasted element. The tree name is L6. So change the dimensions of this element. So now here this X position is other end is minus. So minus 25.865 minus 25.865 plus, so this X size length is 13.32. So plus 13.32. So which is equal to minus 12.545. So that is the X position of the inductor L6. So minus 12.545. And Y position is 1.1 by 2. Z position is 0. Now press the OK button. So this is another end of the inductor element L2. And after this inductor element, we can design another open circuited stub. Another open circuited stub. This one and this one. So this open circuit stub, this length is L3 is 9.58 mm and width is 5 mm. Select the rectangular sheet, draw the rectangular sheet anywhere in the plane. So give the rename of this rectangular sheet. So that name is capacitor C3. And this is capacitor C3 and capacitor C5. Capacitor C3. So now change the dimensions of this capacitor C3. And X position is 12.545 mm and Y position is 1.1 by 2, Z position is 0, X is the Z axis and X size is minus 5 mm and that length is 9.54. So minus 9.54. So press the OK button and select this element, press Ctrl C Ctrl V. So give the rename of this element. This is capacitor C5 element and change the dimensions of this element. So now where the X position is 12.545. So minus 12.545 plus Now the x size is minus 5. So minus into minus plus 5 plus 5. So which is equal to minus 7.545. So now the x position value is minus 7.545. And y position is 1.1 by 2. Z position is 0. Now press the OK button. So this is another end of the element, capacitor C5. And after that, draw the another element, next element, inductor L4. So this inductor L4 width is 0.1 mm and length is 15.09 mm. Select the rectangular sheet, draw the rectangular sheet anywhere in the plane. So give the rename of this rectangular sheet. This is inductor element L4. So now change the dimensions of the element, this inductor L4, and x position is 7.545 mm and y position is 0.55, z position is 0 and x size is 15.09 minus 15.09 mm and y size is, that width is 0.1, so minus 0.1 mm. So press the OK button. So this is the general layout. This is the layout of the 7-pole lumped element low pass filter. And this is 50 ohm transmission line. And this is also another end of the 50 ohm transmission line. So this is the element, capacitive element C1, inductive element L2, capacitive element C3, inductive element L4, capacitive element C5, inductive element L6, capacitive element C7. And after that select 50 ohm transmission line both the ends and capacitive elements C1, C3, C5 and inductive elements L2, L4, L6. Press unite button. So all are unique. And after that design force and rotate the structure, and this is y axis, z axis. Select YZ plane. Select the rectangular sheet, draw the rectangular sheet anywhere in the plane. So give the rename of this rectangular sheet. This is port 1. Now change the dimensions of the port 1 and axis is x axis and x sizes and width of the 50 ohm transmission line. The width of the 50 ohm transmission line is 1.1 and height of the substrate is 1.27 mm and jet size is minus 1.27 mm and the position and x position is 40.865 and y position is minus 0.55 and z position is 0. Now press OK button. And similarly draw and another end of the port. Select this port 1, press Ctrl C, Ctrl V. So change the dimensions of port 2. So the x position is minus 40.865 and rotate the structure. So this is another end of the 50 ohm, another end of the port. Now assign lumped port excitation of port 1 and port 2, and this is port 1. Select port 1, right click on the port 1, go to assign excitation, lumped port, select new line integration, draw the new line integration from lower port to the upper port. So this lumped port excitation line integration is successfully defined. And rotate this structure and another port assign lumped port excitation. Select port 2, right click on the port 2, go to assign excitation, lumped port. Take the new line integration, draw the new line integration from lower port to the upper port, successfully defined, and this is second port. So now coming back to XY plane and select this 50 ohm transmission line and ground plane, right click on that position, go to assign boundary, select perfect electric boundary, click OK button. So this is perfect electric boundary. And after that, assign analysis setup, go to the simulation, select advanced. So now the operating frequency is 1 GHz and selecting maximum number of passes are 12, maximum delta S is 0.02. So press OK button. Select the sweep type is fast and minimum starting frequency is 0.5 GHz and ending frequency is 3 GHz and points are 101. Press OK button. And after that assign open region radiation boundary. Go to the model, right click on the model, select create open region, operating frequency is 1 GHz, click OK button. So this is open region radiation boundary. Now go to the simulation, check the design validation, check validate button. So this design is successfully validated. Now start the simulation, press analyze all button. So simulation is successfully completed. Next observe the S parameter plot and insertion loss plot or transmission plot. So go to the results, right click on the results, go to create model solution data report, select the rectangular plot, select S11, select S parameter S11 and S21 in decibel. So S11 is the S parameter or return loss plot. S21 is the transmission plot or insertion plot. So now click the new report. So this red color curve is the return loss plot and this green color curve is the insertion loss or transmission plot.